Hello, today we're gonna talk about electromagnetic induction. Our members are Chayut, Thanabodee, and Anuphong.
So today we're going to talk about the electric motor. The main purpose of the electric motor is to convert electrical energy into mechanical energy. It was first discovered in 1820 by Andre Marie Ampere. We can see an electric motor in our daily use items such as computer, electric shaver, electric toothbrush, or a washing machine. And there are more. Okay, and today I'm going to explain to you about how it works. So electric motor use electromagnetism. Electric motor create magnetic field with electric current through a coil. The magnetic field then causes a force to generate movement or spinning motion that runs the motor. But there are some rules that need to be applied. The first and BIL need to be constant. The next one is the torque rules, which are F equal BIA, which we use it to calculate the force. And the last one is the Fleming left-hand rules. So how these rules work is, first we hold out our thumb, first and second finger from the left hand. And if we point the second finger in the direction of a current, then the first finger is in the direction of the field, and the thumb will show where the wires move.
As you can see in this picture, we have magnet, the turbine of conductor, commutator, and branch. Magnet produce magnetic field, as in the picture. There are no electric current yet, but as the turbine move, according to Faraday's law, when there are changes in flux, they will be causing electric current. We can calculate flux by BA cos theta. As we can see in this picture, we have magnet, turbine of conductor, commutator, and branch. Magnet produce magnetic field in the picture. There are no electric current yet, but as the turbine moves, according to Faraday's law, when there are changes in flux that will be causing electric current, we can calculate flux by BA cos theta. In this flow of electric current, we can use Fleming right-hand rule or Lenz's law to determine electric current direction. In this case, we can use Lenz's law, as it states that induced current try to maintain the original magnetic flux, resulting in alternation of currents. Let's say, after it rotates for half a turn, it will perpendicular to magnetic field. That means the theta will be 180. So as in the formula of how to calculate the flux, when cos 180 is equal to -1, so that means it will be resulting in the opposite direction. So after it turns, every half turn, there will be change in current direction. And as the coin rotated, it induced electromotive force or EMF. We can calculate by EMF equal MVA watt sine theta. Next, we have commutator and branch to prevent the tangling of wire as it rotates. Commutator is two rings of metal, each connected to one wire only, and they is connecting to branch so that there are the flow of electric current. There are two types of commutator. They are AC type, which is alternating current, because when the direction of electric current reverse, the electric current that flow to the bulb will reverse too, so that it will continuously reverse as it go on. And the next one is DC type, which stands for direct current. It is split ring, which will help us to prevent the reverse of electricity flow in the wire to the bulb. There are two types of commutator. They are AC type, which is alternating current, because when the direction of electric current reverse, the electric current that flow to the bulb will reverse too, so that it will continuously reverse as it go on. And the next one is DC type, which stands for direct current. It is split ring, which will help us to prevent the reverse of electricity flow in the wire to the bulb. As we can see, an electric motor and an electric generator have the same likely structure and function according to the same mechanism. Electric motor is converting electricity to create the motion, and the electric generator create the electricity from the mechanical energy. So it's normal to have the similar structure, as you can see.
So come to the real life example of induction. In this video, I will talk about solenoid valve. A solenoid valve is an electrically controlled valve. The valve features a solenoid, which is an electric coil with an movable ferromagnetic core or plunger in its center. In other words, it is a remote control of a valve via a circuit. So there is a basic principle that is used to open and close the solenoid valves. So basically, we just apply the current into the coil, which will create a magnetic field. Then, magnetic field will exert an upward force on the plunger to open the valve. So first, in this picture, we can see that the fluid is blocked because there's no current in it. And when the current is on, the magnetic field around the wire passes through coil ferromagnetic plunger, which make the plunger to move up and then open the valves, which make fluid flows. On the other hand, when the current is off, the magnetic field disappears and spring mechanism moves the plunger back. So when the flow is stopped, the core must have low retentivity and cohesivity. There were some control factors in the solenoid valve, which are direction of current through the coil, changes poles or magnetic field direction, pull or push force on the plunger. So first, in this